The ones under the ice. In February 1977, a submersible called Alvin was lowered into the Pacific near the Galapagos Rift. The team on board, led by the geologist Jack Corliss, was looking for hot water. 2.5 kilometers down, in complete darkness, the lights picked up meter-long worms, white crabs, and beds of clams around a crack in the seafloor. Nothing there had ever seen the sun. Biology at the time held that every food chain on Earth began with sunlight. This one began with hydrogen sulfide leaking out of rock. That is why anyone looks at Europa at all. Europa is a moon of Jupiter under 15 to 25 kilometers of ice, with an ocean beneath it holding twice the water of every ocean on Earth combined. Enceladus, a moon of Saturn 500 kilometers across, has the same thing. In 2005, the imaging team on Cassini, led by Carolyn Porco, saw jets firing out of the south pole of Enceladus. In October 2015, Cassini flew straight through one of them, 49 kilometers above the surface. Hunter Waite published the result in Science in 2017. The plume contained molecular hydrogen. That points to water reacting with rock on the ocean floor right now, the same chemistry that fed the worms at the Galapagos Rift. In 2023, Frank Postberg found phosphates in the same material, the last of the 6 elements our own biology is built from. Anything living down there would have no eyes. It would sit on a vent in permanent darkness and take its energy straight out of the seafloor. Europa Clipper arrives at Jupiter in 2030, the ones that never land. In 1976, Carl Sagan and Edwin Salpeter published a paper in the Astrophysical Journal supplement series, not as speculation, but as physics. Jupiter has no surface. There's no boundary between atmosphere and interior. The gas just gets denser until it turns into liquid metal. Sagan and Salpeter asked what an organism would need to survive with nothing to stand on. The physics allowed exactly 3 answers. The first they called sinkers: small, passive, falling constantly, reproducing on the way down before the pressure destroys them. That's the easy one. Staying up is the hard one. The second they called floaters. To hold altitude, an organism would have to pump the heavier gases out of itself and keep hydrogen inside, the way a balloon works. Salpeter ran the numbers. A floater capable of staying level in Jupiter's atmosphere would have to be kilometers across, a living thing the size of a city drifting. The third they called hunters: fast, jet-propelled, feeding on floaters. Sagan animated all 3 for Cosmos in 1980. It's still the only time a hypothetical ecosystem has been drawn from buoyancy equations. On the 7th of December 1995, the Galileo probe entered Jupiter's atmosphere. It lasted 58 minutes and reached 156 kilometers down before the pressure ended it. It never found a bottom, and that was the point. Sagan's animals wouldn't need one. Salpeter rated the odds as very low in the paper itself. His argument wasn't about probability, it was structural. Jupiter's atmosphere has been circulating for 4.5 billion years, and physics has never ruled it out. The ones that don't burn. Everything alive on Earth is built on carbon and runs on liquid water. Both are local conditions, not laws. In 1891, the astronomer Julius Scheiner suggested silicon as a replacement for carbon. It sits directly below carbon on the periodic table and forms 4 bonds the same way. In 1954, J.B.S. Haldane took it further, arguing that on a planet hot enough to keep silicates molten, silicon would have the flexibility carbon has at our temperatures. The stronger case is a cold one. On the 14th of January 2005, the Huygens probe landed on Titan, the largest moon of Saturn. It's still the only landing ever made in the outer solar system. It transmitted from the surface for 72 minutes. Titan sits at -179 degrees Celsius with rain, rivers, and lakes, none of them water, liquid methane and ethane. When the probe's warm body struck the ground, its instruments recorded methane evaporating out of the soil underneath it. The ground was damp. A cell in that cold can't use a fatty membrane. It would freeze solid. In 2015, James Stevenson, Jonathan Lunine, and Paulette Clancy at Cornell modeled a membrane built from acrylonitrile instead, and found that in liquid methane it holds together and stays flexible. They named it an azotosome. 2 years later, acrylonitrile was detected in Titan's atmosphere, in quantities large enough to rain out. Nothing has been found there yet. Dragonfly launches in 2028, and it will fly across Titan's dunes looking, the ones that live inside a second. In November 1967, a graduate student in Cambridge named Jocelyn Bell Burnell found a signal on her chart recorder that repeated every 1.33 seconds. The regularity was the problem. Nothing known in astronomy kept time like a clock. Her supervisor, Anthony Hewish, checked for interference and found none. For several weeks, the group seriously discussed what to do if the source turned out to be a transmitter. They labeled the file LGM1, Little Green Men. Then Bell Burnell found a second source in a different part of the sky and the idea collapsed. She had found the first pulsar, a neutron star, roughly the mass of the sun, packed into a sphere 20 kilometers wide. A teaspoon of it weighs about 1 billion tons. On the surface, gravity is 100 billion times what it is here. In 1973, Frank Drake, the astronomer who wrote the equation for how many civilizations should exist, published a calculation in Astronomy magazine. On the crust of a neutron star, matter isn't held together by chemical bonds. It's held by the strong nuclear force, which is far stronger and acts 1,000,000 times faster. Drake's argument was that if structures can form there and copy themselves, they'd be roughly the size of a bacterium, and they'd live at that speed. A civilization on that crust would begin and end inside 1 of our hours. Nobody has tested it, and nobody can. The nearest neutron star is 400 light-years away, and anything we sent to the surface would be flattened into a film 1 atom thick. The ones made of light. Everything so far has been chemistry of one kind or another. Chemistry is rare. More than 99% of the visible matter in the universe isn't solid, liquid, or gas. It's plasma. Stars are plasma, and so is most of the material between them. In 1957, Fred Hoyle, the best-known astronomer in Britain at the time, wrote a novel about an intelligent cloud of gas arriving in the solar system. His reason wasn't literary. Hoyle argued that a molecular cloud has more internal structure and more free energy available to it than the surface of a planet, and that nobody had checked whether that structure could do anything. In 1980, Gerald Feinberg and Robert Shapiro gave the idea a name, plasmobes. In 2007, Vadim Saitovich and Gregor Morfill published a modeling study in the New Journal of Physics. They simulated dust grains suspended in plasma, a common state found in Saturn's rings and star-forming clouds. In the simulation, the grains organized themselves into double helices. The helices were stable. They divided. The new structure carried the same arrangement as the one it came from, flaws included: self-organization, division, inheritance. No organic molecule anywhere in the system. Morfill wasn't working from theory alone. He'd been running plasma crystal experiments on the International Space Station since 2001, where the dust stops settling and the structures hold their shape long enough to photograph. No laboratory has reproduced the helices, and the paper is still disputed. What isn't disputed is the proportion. We're looking for life inside the 1% of matter that happens to resemble us, the ones that were built. On the 15th of August, 1977, a radio telescope in Ohio called Big Ear recorded a narrow signal at 1,420 megahertz, the frequency of neutral hydrogen. It was 30 times louder than the background and lasted 72 seconds, exactly how long the beam took to sweep past a fixed point in the sky. Jerry Amon found it on the printout 3 days later, circled the 6 characters, and wrote 1 word in the margin. Wow. Big Ear looked again the next night and hundreds of times since. Nothing has ever come back. That signal is now used for an argument. A species invents radio, and a few centuries later it invents machines that think. Seth Shostak at the SETI Institute has made the point for 20 years. Biology is a phase. It lasts a few hundred years out of a few billion. If anything is transmitting, the odds are that it stopped being flesh a very long time ago. Something built wouldn't need a habitable planet. It wouldn't need water, oxygen, or a day and a night. It would need power and cold, and both are easier to find away from a star than near one. It wouldn't age. It could sit still for 1,000,000 years and lose nothing. Freeman Dyson wrote The Search Strategy in Science in 1960. A civilization that lasts eventually needs more energy than its planet receives, and the only place to get it is the star. Dyson's argument was to stop listening for messages and look for waste heat. In 2015, Jason Wright's team searched 100,000 galaxies in infrared for exactly that. Every one of them was normal. The ones already here. On the 30th of July, 1976, the Viking 1 lander ran an experiment on Mars designed by Gilbert Levine. It was called Labeled Release. A spoonful of Martian soil was fed a nutrient solution tagged with carbon-14. If anything in that soil was feeding, it would give the carbon back off as gas, and the detector would see it. The detector saw it. The curve had the shape a living sample produces. A control sample, heated to sterilization first, produced nothing, exactly what a biological explanation requires. By the criteria written before launch, the test was positive. Then, a second instrument on the same lander found no organic molecules in the soil at all, and the result was reassigned to perchlorate chemistry. Levin argued for the rest of his life that Viking had found life in 1976. He died in 2021, still arguing it. In 2005, Carol Cleland and Shelley Copley wrote down the problem underneath all of this. Every test we have looks for our biochemistry, our amino acids, our sugars, our twist. An organism with a separate origin wouldn't register as life. It would register as contamination and be filtered out. They called it the shadow biosphere. And it wouldn't be on Mars. It would be here, in the same soil and the same water as us. In December 2024, 38 scientists published a statement in Science calling for a halt to all work on mirror life, a cell built from molecules with the opposite twist to ours. Not because it can't be made, because no immune system on Earth would recognize it. 7 kinds, one under ice, one that never lands, one that can't use water, one living 1,000,000 times faster than we do, one made of dust and charge, one that was built and doesn't age, and one that may already be sharing the planet with us. Every one of them was put forward by someone with a name and a date. Not one has ever been found. The instrument said yes once, in 1976. We decided it was wrong.